Good morning, everyone, and thank you for the opportunity to show my presentation. The topic of my research is forensic perpetrator identification utilizing foot pressure under shoes during gait. I'm the first author, Ammar Majeed, School of Engineering and Surveying, University of Southern Queensland in Toowoomba, Australia, and University of Baghdad in Baghdad, Iraq. Second author is Dr. Albert Chong, who's photographed here. School of Engineering and Surveying, University of Southern Queensland, Toowoomba, Australia. The aim and objectives for this research. The aim was to exploit the under the shoes force and pressure measure to identify any individuals through gait characteristics. We have two objectives. The first one is to discover which under the shoes force and pressure measure to suitable for forensic application, and the second objective is to determine the suitability of these measures for identification perpetrator from suspects based on a small number of suspects. Introduction. Literature review showed that identifying perpetrator using gait characteristics could be the only suitable techniques in some crime scenes. A number of authors argued that perpetrators might have walked differently than the normal walking pattern when the crime was committed, which caused matching of the gait pattern with suspect difficult. In addition, there were numerous gait characteristics developed to date, and their effectiveness were not fully understood for a small sample size. The concept of force pressure under the shoes. By placing force pressure sensors under the carpet, we could record the under the shoes force pressure data together with the lower limb movement. Three major gait characteristics could be identified in the under the shoes force pressure data, such as heel down, mid stance, and toe off. These main characteristics were selected as the markers for comparing the force pressure pattern and size of force pressure between individuals. The equipment used in this research is the ISCAIE International pressure plate, which is of length 2 meter, and use the foot scan software. This is the dimension of the plate, and there is a 3D interface box developed by ISCAIE International in Belgium. Each sensor covers 2.2 millimeter square. The plate was composed of 16,384 pressure sensors, and the system is capable of scanning a rate of up to 500 Hz or 500 measurements per second. Recruits: 13 adults age of 34 plus minus 1 year old, weight 79 plus minus 20 kilograms, and height 171 plus minus 11 centimeter were recruited to provide gait characteristics data for this research. The small sample size selected was based on the common number of suspects in a crime investigation. Subjects wore similar brand shoes, thus the impact of different shoes sole pattern were reduced. Methods. Each recruit executes 10 trials starting with left foot and 10 other trials starting with the right foot. The length of pressure plate provides a 3-4 steps continuous gait. The under the shoes force pressure data collected from the second step, which is the right step for foot, and that is starting with the left foot. Gait is more stable from the second step. Results and analysis. Figure 2 here shows an under the shoes loading phase gait force and pressure image for a typical recruit. In this figure, A shows the toe off phase force loading, and B shows the selection of step 2 of the first 3 steps during trial. C shows the left foot total force loading, and D shows the right foot total force loading. Also, in the figure of foot medial axis FMA line and the center of pressure center COP line dotted line are displayed. In addition, the angle of heel down with reference to the MFA and the initial COP direction can be determined accurately. These are some of the significant gait measures that could be collected during Gait. Table 1 shows the result of one-way ANOVA analysis of variance of the 13 recruits. The mean and standard deviation of 10 trials, together with the maximum and minimum values, were depicted in the table. Note the small size of the standard deviation. Figure shows a scattering plot of the mean and standard error. It is clear that the mean between individuals varies hugely. However, the standard error of the 10 trials of each individual are similar in size, crossbar, indicating the high precision of the measure. Note the statistical testing results. Between groups, the significance of similarity between individuals' measure was very small. That means everyone's measure was very different from the other. Second, within groups, the significance of similarity within individuals' measure was very high. That means everyone's measure are unique, different to the other. Discussion. In the figure, a vertical bar chart of the force pressure measure of the 13 recruits. Note the small size of the standard error at the top of the bar. This shows a high precision of the measures. In conclusion, these measures are suitable for the determination of perpetrator from a group of suspects. As discussed in the review, the statistical significance satisfies the requirements needed for the forensic evidence of biometric measures. Further work will involve the recruitment for more subjects, the integration of force pressure and physical dimensional measures have a huge potential in finding suitable ways to separate perpetrators from suspects. These potentials provide excellent research opportunities for the betterment of forensic science. Acknowledgements. The author thanked the Iraqi highest degree research students group of their participation. Without their enthusiastic support, these projects would not have been successful. The first author thanked the Iraqi government for his study and support in Australia. Thank you very much for your listening.